Okay guys, so let us look at this question. So the question is saying that we have to explain the following cases. Okay, so we have to explain the following questions. So the first question is that why is tungsten used almost exclusively for filament of electric lamps? So for that we have to understand what is the filament doing in electric lamp. Okay, so electric lamp, it is used to produce light by making the filament glow. Now this filament will glow when it becomes very hot and it produces a lot of heat. So actually the filament becomes very hot, and we should use a material which should have a very high melting point, okay, so that the filament does not melt. Also, in order to produce a lot of heat, we know that Joule's law of heating. So from Joule's law of heating, we know that heat produced is directly proportional to resistance, and resistance is very dependent on resistivity. Resistance is directly proportional to resistivity. So resistance will be very high if resistivity is very high. So we actually need a material which is having very high resistivity and very high melting point. So tungsten is an example of a substance which is having very high melting point and very high resistivity. So tungsten is exclusively used for making the filament of electric lamp. Now let us look at the next part. So the next question is, why are the conductors of electric heating devices such as toasters and electric irons made of an alloy rather than a pure metal? So we know that usually pure metals, they have lower melting point as compared to alloys, and they have low resistivity as compared to alloys. So alloys, when compared to pure metals, they have very high melting point and very high resistivity. We can make alloys of those materials, okay, which have very high melting point and very high resistivity. Example of such alloy is nichrome. So nichrome is used in electrical heaters, okay, and nichrome is an alloy of nickel and chromium. So that this is the reason why alloys are used to produce heating devices, to make heating devices instead of pure metals. Now let us look at the next part. So this part is saying, why is series arrangement not used for domestic circuits? So let's say that we have a bulb, a TV and a refrigerator all arranged in series to 220 volts mains supply. Now we can draw the circuit diagram, equivalent circuit diagram like this. So here we can see that the potential difference across the bulb is not 220, it is V1. Or okay, similarly the potential difference across the TV is also not 220, and same for the refrigerator. So, and you guys know that this 220 volt is divided among these bulb, TV and refrigerator, and it will be divided according to their resistances. So the potential difference across the bulb or the TV or the refrigerator is actually not 220, it is less than that. Okay, so there is voltage division in series circuit. So each device in the circuit receives a small amount of voltage even if you apply a large voltage. So suppose you are applying 220 volts, but the appliance is getting very less than 220 volts. So this is the reason why series arrangement is not used for domestic circuits. Now let us look at the next part. So this question is saying, how does the resistance of a wire vary with its cross-sectional area? So we know that R is equal to rho L by A. We know that resistance is equal to rho L by A. Okay, so from here we can see that we know that resistance is inversely proportional to the area of cross-section. So resistance of a wire is inversely proportional to the area of cross-section. Now let us look at the next part, last part. So why are copper and aluminium wires usually employed for electricity transmission? So we know that for electricity transmission, the wires should have very low resistance. Okay, the wires should be very good conductors. We know that silver is the best conductor, but it is very expensive. So we can use silver if we are very rich, but we are not that rich. So what we do? We use copper and aluminium wires because they have very low resistivity, not as low as silver, but still very low. And they are good conductors. They are not as good conductor as silver, but they are good conductors. Okay, so copper and aluminiums are used as substitute for silver, and therefore copper and aluminium wires are used for electricity transmission. So these are the required answers for this question.